Math 3, Spiral Review, Rational Equations. Solve each equation. Remember to state domain restrictions. Any value of the variable that makes one of the denominators 0 would be considered a domain restriction. I will go over most of these problems, but not all of them. Anything we don't go over in this video, you can check the answer key that I will post. So we'll start with number 1 and then skip around a little bit. So on number 1, we want to state our domain restrictions. So n cannot be equal to 0. I figured that out because I looked at my denominator, and this one, if n was 0, the denominator would be 0. And then same thing over here, 2n equals 0, divide by 2, divide by 2. So n would be equal to 0. And we don't want the denominator equal to 0. As far as actually solving rational equations, there are multiple ways to do it. The way I went over in class is I said, let's identify the least common denominator, and then let's multiply every single term in the equation by the least common denominator to get rid of all of the fractions. So the least common denominator is going to be the least common multiple of all the numbers you see in the bottom. And then as far as the variables go, it's basically all of the variables you see in your least common denominator. It'll make a little more sense as we go over it more. So as far as the number part of the least common denominator, we're going to go with 2 because that's the only thing there. And then the variables, there's just a single n. So 2n is our least common denominator. So we're going to multiply every fraction by 2n. Let me zoom in a little bit here. So everything's getting multiplied by 2n. And again, the whole point of doing this is to cancel out the fractions so that we don't have to deal with any fractions at all. So let me switch my colors up. 2 divided by 2 cancels out. N divided by n cancels out. And then 2n divided by 2n cancels out. So as far as the leftovers, in that first fraction, 1 times n is n. 2 times 2 is 4. 1 times 1 is 1. Because remember, the 2n canceled out completely, so there's just a 1 left over in that far right fraction. And then solve like normal. So minus 4, n equals -3. And then we always want to kind of double check and make sure that our answer wasn't a domain restriction. So n equals -3 is fine because our only domain restriction was the fact that n could not be equal to 0. Let's take a look at number 3. And actually, let's at least get the LCD for number 2 and the domain restrictions, and then I'll let you do the rest of it and just check the key later. So on number 2, as far as domain restrictions go, just look at your denominators. V cannot be equal to 0, because if it was, it would make the denominator 0, and when you divide by 0, that's undefined. And then for the least common denominator, I see a 3 and I see a V. There is nothing else in the denominator, so that's going to be our least common denominator, 3V. Now let's jump to number 3. So on number 3, let's start with domain restrictions. So if we had r squared equals 0, when you square root both sides, r is 0. Same thing over here, 2r equals 0. You divide by 2, you divide by 2, r equals 0. So r cannot be equal to 0. That's our domain restriction. And then for our least common denominator, we have the 2. And then instead of just r, we want to go with r squared, because some of these fractions have an r squared in the denominator. And since there's 2 r's being multiplied together in one spot, we need to have that in our least common denominator. So now we multiply every fraction by the least common denominator. So 2r squared, 2r squared, 2r squared. And then we're going to cancel some common factors. So in that first fraction, the r squared cancels out with the r squared. In the second fraction, 2 divided by 2 cancels out to 1. And then this r is gone completely, and then this r squared turns into just an r, because r squared divided by r is a single r. And then in that last fraction, r squared divided by itself cancels out completely. So in that first fraction, the only thing left is 1 times 2, which is 2. In the second fraction, the only thing left is 1 times r, which is r, minus 5 times 2 is 10. And then we just solve like normal. So plus 10, r equals 12. Let's make sure that's not our domain restriction. Good, it's not. So r equals 12 would be our final answer. And then our domain restriction was that r could not be equal to 0. On number 4, for our domain restriction, x cannot be equal to 0, because if it was, it would make these two denominators 0, and we can't have that. And then for our least common denominator, I'm looking at the 3 and the 6. So the smallest multiple of 3 and 6 is 6. I think a lot of time people get confused between multiples and factors. If I was thinking of multiples of 3, I would basically be counting by 3. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and so on and so forth. Multiples of 6 would be counting by 6. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and so on and so forth. So the smallest multiple that 3 and 6 share is 6. So that's why 6 is going to be part of our least common denominator. And then for our variables, we see an x squared. So we're going to want to multiply everything by the least common denominator of 6x squared. And again, the whole point of multiplying everything by the LCD is to cancel out all the fractions. So in that first fraction, the 6 divided by 6 cancels out. In the second fraction, 6 divided by 3 is 2. So this 3 is gone completely, and then this 6 turns into a 2. And then the x squared divided by x squared cancels out completely. In that last fraction, 6 divided by 6 cancels out to 1. X squared divided by x squared cancels out to 1. So the only thing left in that first fraction is 1 times x squared, which is just x squared. And then in that second fraction, the only thing left is the 2. Now be careful, it's 2 times the whole numerator of that second fraction. So 2 and then parentheses, x squared plus 3x minus 10. And then in the back, that minus sign needs to get distributed to the x and to the 4, so be careful with that. From here, we should just solve like normal. So x squared equals, and then we need to distribute our 2 to everything in the parentheses in the back, and then distribute this negative sign to everything in the back. And then we should solve like normal. On the right side, let's combine any like terms we have. So 6x minus x is 5x. And then negative 20 minus 4 is negative 24. And then since this problem has x squared terms and x terms, we want to get everything on one side and set it equal to 0 so that we can factor and solve. So I'm going to subtract x squared from both sides of the equation. That way I have 0 equals, and then everything else. All right, so it looks like we're down to a basic trinomial. So there's no GCF that we could factor out. We want to find two numbers that multiply to negative 24, and then those same two numbers need to add up to 5. So it should be 8 and negative 3. And then at the end here, set each factor equal to 0, solve for x. So we're getting -8 and 3. Let's see, were either of those domain restrictions? No, x is not equal to 0 was a domain restriction, and both of those are not 0. So that means we get to keep both of those answers. All right, so obviously that was a little bit more of an involved problem. On 5, let me just get you started. I'll let you finish it and check the key later, and then we could do all of 6. So on 5, as far as domain restrictions go, that last fraction is a basic trinomial that we can factor. So we should do that first before we try to get our domain restrictions. So we're looking for two numbers that multiply to -5 and then add to 4. So let's try 5 and -1. I think that works. Yes, 5 times -1 is -5. 5 plus -1 is 4. So as far as domain restrictions, you can't have n be equal to -5, because if it was, it would make this 0 and it would make this 0. We also cannot have n equal 1, because if we did, it would make this 0 and it would make this 0. And you can't have 0 in any of your denominators. So we have two domain restrictions. For the least common denominator, it's basically one of everything we see as far as factors go. So we see an n plus 5 and we see an n minus 1. So that's going to be our LCD, n plus 5, n minus 1. And then you can go ahead and finish the rest of that problem. On 6, sort of similar to 5, we want to factor that trinomial in the bottom of the second fraction. So we're looking for two numbers that multiply to -5 and add up to -4. So -5 and 1. So for domain restrictions, x cannot be equal to -1, because if it was, it would make this and this and this equal to 0, and we can't divide by 0, it's undefined. And then x cannot be equal to 5, because if it was, this would be equal to 0, and we can't divide by 0. For the least common denominator, it's one of all the factors that we see. So we see an x plus 1 in the denominator. We see an x minus 5 in the denominator. Even though we see multiple x plus 1s, we just have a single x plus 1 in our LCD, because in each individual fraction, there's only a single x plus 1. If you pretend for a second, I'll erase it, but if you pretend for a second like this was like this, x plus 1 squared, then our LCD would have to be x plus 1 squared. So it's as many as you see in one single fraction. But since there's only one per fraction, we just need the single x plus 1 in our LCD. Let's go ahead and multiply everything by our LCD. So this is times x plus 1, x minus 5, and then same thing over here, x plus 1, x minus 5, and x plus 1, x minus 5. So in that first fraction, x plus 1 cancels with x plus 1. In our second fraction, x minus 5 and x minus 5 cancel, x plus 1 and x plus 1 cancel. And then in that last fraction, x plus 1 and x plus 1 cancel. So now there's lots of multiplying. Keep in mind all of these numerators up top, think of them as having invisible parentheses around each one, because you do need to do a lot of distribution. So on that first fraction, you have x minus 1 times x minus 5 plus that second fraction, we're in luck. It's just 3x squared plus 9x minus 12, because everything had canceled out. And then on that last one, 1 times anything is just that anything. So 1 times x minus 5 is just x minus 5. So I guess the only really obnoxious thing is way up at the front here. We need to FOIL. So first times first is x squared. Outside times outside is -5x. Inside times inside is -1x. Last times last is 5. And then we'll drag down everything else and combine like terms and solve for x. So I have an x squared plus 3x squared, so 4x squared. And then I have negative 5x minus 1x is negative 6x plus 9. So negative 6 plus 9 is 3x. And then for our constants, 5 and minus 12 is negative 7. And then drag down the equals x minus 5. Since we see x squared terms and x terms, we want to get everything on one side and set it equal to 0 so that we can factor and solve. So I'm going to subtract x on both sides and add 5 on both sides. So 4x squared plus 2x minus 2 equals 0. And then looks like there's a GCF of 2. So I want to divide a 2 out of everything because there's a greatest common factor of 2. And then as far as our leftovers in the parentheses, you could do advanced factoring or you could kind of do guess and check. Since the numbers are so small, we might be able to get away with guess and check fairly easily. So if I'm doing guess and check, I took that 2x squared and I split it into 2x times x, because that's really the only way to split it up. And then I need to pick numbers that multiply to negative 1, but then they have to add up to positive 1 in the middle. And the thing that makes it a little tricky, though, is that there's this 2 here in the front. So we do have to do a little bit of guess and check. So as far as negative 1 goes in the back, I know I need a 1 and a 1. The only thing that's tricky is that I have to figure out which one is positive and which one's negative. Since I'm trying to add up to a positive 1, I need to have this first one negative and then this second one positive. And then what I'm going to do is I'm going to kind of check this in my head real quick to make sure it actually works. So I'm looking at 2x times 1 is 2x. And then I'm looking at negative 1 times x is negative 1x. 2x minus 1 is x, which is perfect because I was supposed to add up to x. So that means, yes, we have factored that correctly. And then as far as finishing this problem off, let me drag this over here. We're just going to set each factor equal to 0 and solve for x. So that first factor, 2 equals 0, that doesn't make any sense. 2 does not equal 0. So that is just kind of an extra factor that we can ignore or cancel out. The other way to think about that 2 in the front, so this one right here, you could have just divided both sides by 2 to cancel out the 2. So either way you think about it, that 2 is kind of gone. And then as far as the other two factors, we have 2x minus 1 equals 0. And then we have x plus 1 equals 0. So then we just solve like normal from here. So 2x equals 1, divide by 2, x equals a half. And then x equals negative 1. So we have our two answers. Are either of those domain restrictions? X could not be equal to negative 1, and x could not be equal to 5. So that first answer, x equals a half, is totally fine. But then this second answer, x equals negative 1, we have to cross that off because x equals negative 1 was a domain restriction. X could not be equal to negative 1. So we have to cross off that second answer. So go ahead and try those couple problems that we didn't finish together, and then I'll put the answer key up so that you could check those couple that we didn't go over in this video.